Okay, now it's recording, and yeah, just for our listeners, today we can't stream. The stream is not working for some reason, and this time we are like recording it, and I hope next time is the stream working again. Today, K. Neunert is going to show us something about vibe coding. He has made great discoveries and great progress on how to better vibe code for the Specter DIY. And he even prepared a PowerPoint about some things he found out. And yeah, do you want to add something or directly start, Kanoinat?
Yeah, I would say let's start directly. I created it this morning with the help of AI because I'm not a great PowerPoint creator. So I just simply had a conversation with AI, which then created some slides for me. So yeah, and it's somehow also a kind of rant by me because I think our project is a little bit uh, in trouble because of several reasons. I will go into the slides here. So Stepan has left, and sometimes he is available for very, very urgent things, but in general, we cannot rely upon him. And Mike can't work
So,
without funding. Um, but we also have,
Stepan is the maybe like to add some context for like new, or maybe that's
yeah,
okay. This should be like
so Stepan Snigirev is the one who initiated from a technical side the whole project, and he did the main work for the Spectre firmware together with Mike. And now we have, yeah, Stepan unfortunately left, and we have Mike who is still working, but he can't do it for free, so he needs funding. And we already did some work which we covered in the last calls, but there's still stuff which is not solved. However, we also got a couple of people. So Marco is very engaged and enthusiastic about the new mock UI. Crypto Guide contributed a lot. Schnurz is driving the whole thing a little bit, and Tadeo just recently made great contribution working for the M3Y problem. And so, yeah, the community is somehow alive and working, but we had some kind of brain drain, I would say, right? So we are stuck, from my point of view, on 2 points. The first point is that the firmware doesn't build in a flashable way. And I'm talking now about the new firmware, not about the old one, right? So the old one is still working, but we need a refurbishing. The project hasn't seen any kind of maintenance task for a couple of years. And yeah, and we started it, but it's not yet finished. We can't flash it to the hardware. Um, and the solution for that is that Mike gets some funding, and we apply for some funding, but it's not clear whether we will get some funding, and it takes time. And we hope for the best, but I don't want to only hope. So it's not a good plan to only hope. So, and then the second stuck point is the Python code. So I think a lot of people think, okay, it's fine to just go with the old firmware, but I think it's really, really reasonable to do a new one. And for the new one, we need a lot of refactoring, and that is something which takes an enormous effort, which we might not have, right? So that's not denied. Yeah, let's jump over here. So this is a nice example from AI. It told me it's a little bit like PGP, right? So it has and that is only for the stuck point number 2. So if we would have a new nice firmware, we might get a lot better adoption. And if we don't, then maybe we got stuck. And then it's like PGP has a bad UI, UX, no one is using it. Yes. So let's jump a little bit. So what can we do about it? So in 2022, I broke my arm during Swan's custody project, and I discovered AI for development, and I even used speech recognition back at the time. And I, for a very long time, I didn't thought that the kind of that AI coding would help us in any way, neither for the mock UI nor for the firmware. But I changed my mind, because what I discovered is somehow the triangle. I call it the triangle, and that is on the one hand side instructions, then autonomy and reality, and you need more or less cover all three of it, because otherwise you will not go to the performance improvements which you need. And how to explain that? So here is often I wanted to have a kind of picture of a child which is standing in front of an oven, and then someone tell the child, the oven is hot, don't touch it. And that's the instruction part or the context part, and the guardrails part, right? So you should not touch it because it's hot. But the child is autonomous, and it touches it anyway, and then it gets hurt. And that's these two parts here. So on the one hand side, it has the ability to do things on its own, and on the other hand, if it burns itself, then it feels the reality, and there is a kind of feedback loop going into which is kicking in, right? And these three things are very, very important, and that helps AI to learn and help us. And I looked at a little bit of the last weeks. I would say two weeks or so. I looked a lot into the different kind of tools, and I'm reading, by the way, also a book which is called Vibecoding by Gene Kim and Steve Yegi. I really can highly recommend that book, and it's very generic, and it doesn't go into tools. But I discovered two tools or three, more or less, which I think can help very much. So on the instructional side, there is the kind of BMAT method, which I, by the way, also used in order to create these slides. And it is able to create a lot of context documents and structure for developing and things like that. Then there is autonomy. I won't go into so much details about it, but it's a project called Beats from Steve Yegi, from one of the authors of the book. He didn't mention it until half of the book that he's created it, but I think it helped me already a lot. And it's a kind of task. It's an issue management system for for AI. So in order for them to manage and track their work. And then we have the kind of touch reality kind of thing, and there are MCP servers. And this is a very, very context specific thing. So it enables the AI to get in touch with reality. So, for example, there is if an AI is connected to Google Docs and can read and write Google Docs, then this is achieved by MCP servers. And we will later look in detail what an MCP server can do for Specter. I did already an MCP server which connected the LVGL simulator with the AI, and it created documents with screenshots, and it's human readable and it's navigable, and it can then do things very much quicker when it has that connection to reality. And this is the the um, the tool for touching reality for the second problem, right? Like building um, the new firmware. And which is very important for that is the kind of guardrails, right? And on the one hand side, guardrails is, for example, creating mock UI. So the mock UI already gives a lot of context for the UI to decide what's wrong and what's right, so what the purpose is, and so on. It's not that it's doing everything automatically. That's not how it works, right? So, but the help of AI is tremendously improving if you have these kind of guardrails, and if you provide that touching reality and the management, the autonomy part of it. Yeah, and then there's, in general, there's usually the problem with security, right? A lot of people think that AI produced code is inherently insecure, and that's simply not true, because if you look at how security researchers are working, they are also using a lot of AI in order to review code. So you can use AI, it's just a tool to review code and write code both, right? And there's also the kind of best practices for creating software is now not neglected. The opposite is true, right? You need test suites in order to track also security bugs and the quality of software in general. You need documentation, you need static analysis, and assistance for security review. This doesn't go away, and this doesn't change because an AI is writing code and not a human being. And last but not least, the attackers are using AI already. So the only way to more or less catch up is to use AI for security reviews as well, obviously, right? Yeah, and so we have to somehow go forward, and AI will help us for that. And yeah. So this is more or less then my kind of call to the community to embrace AI and to look into it. And I will now go to the demo part. Is there anything else? Yeah, some final slides from the AI. Great. So if we don't have any questions so far, I would go into demo mode. If I find it. Yeah, I think I have to go to the entire screen anyway. Okay, so let me make that a little bit bigger. I have to move around because I cannot do this one bigger. Yes, I can. Great. So yeah, so I have two examples of, I even have three examples, right? The AI slides, but I won't go into detail with that. But let's go to the first one, which is already open. That's the Specter playground. Yeah, so let's stop this one. Stop this one. So I'm using a Claude code. It's more or less very similar for the different AI implementations. Can you read my screen, or should I make it even more bigger like this? Is that fine?
Yeah,
Can someone tell? Yeah, it's good. Good. Yeah. So and Claude is working on the console, so you can more or less start it on every kind of a folder, and then it asks you whether it's secure to deal and do things there, and you say yes, and then you have a conversational interface here, right? And what I can do, I won't go into so much details, but more do a demo kind of thing. You can do like please start the simulator. Yeah, and then it asks you some things, and here's the simulator, right? And this is the mock UI from Marco, right? And then you can say something like click scan QR. Yeah, and it's unfortunately it forgets something because I created please use the sim CLI. It sometimes it's forgettable, and we have to adjust. There are specific files where we can do that. Here, for example, there's a Cloud MD where we can tell it how to do things, right? So it discovers now maybe some bugs, and then it's autonomously working around that. And we can now do the click. Now it's scan QR here, right? So go back, and now I want to demo what kind of things we can do from a development point of view. So now we are back. There is, don't ask me again, we can fine tune it later, what kind of commands it can run and what not. Now we are on the main screen again, and now we say, please lock the screen. It might not even know what that means, but it will find it out. Oh, it knows. Screen locked. Oh, that's not true. It's not locked. Make a screenshot. So it can make a screenshot, and it can look at the screenshot, and then it realizes, oh, here, read the screen. Yes. You're right, still showing main menu. Let me check the state and see what's happening. And now it more or less automatically figures out that there is something wrong, right? So on the one hand side, it tells the simulator tells them or one side of the reality tells it something is locked, and the other one it's not locked, right? So now it created another screenshot. And you just have to more or less point the AI to these kind of inconsistencies, and then it more or less will automatically figure out what's wrong and will fix the bugs on the go. Yeah, and what you always have to keep in mind is to check here what kinds of changes it made, so it cannot screw up, because at some point in time it might do very wrong things. And so it's a very active process. You have to control and see what's wrong here. Found the issue, show menu at line 80 to 87 is checks is locked and shows locked menu, but without triggering a UI refresh. Interesting. I need to modify the control server call. Okay, let's do that. And maybe you get the point here of what I'm trying to say, because at some point we also will work with the AI to refactor the old firmware and package it up in proper modules. And when that is done, we can then take these modules and pack them into, yeah, let's continue here in the meantime, and kind of stuff it into the mock UI, and then yeah, we have more or less running software, which is also kind of automatically fixed or much easier to be maintained and fixed. And that is something which really increases the productivity by the factor of 10 or so, at least, right? So I don't even know that this, I didn't plan that. I had no idea, right? That this is, it's just showing how things are working with that. The fix worked. Yeah, okay. So please do another test. Sometimes it's saying that things are working and they don't. So it's always better to push it for checking it again and again until you're really sure that it's working. So we don't have, where are the changes? Specter, this is the new one. This is all. And find, no. I'm a little bit astonished where the code for the playground is. Can't find it at all. But it clearly changed here something in the control server, right? Yeah, it added this one here, and this is the stuff which we now could add and commit and push, right? Yeah, we did another test. Looks good, great. Or maybe not. But you get the idea, right? And that is what I would say. This is the problem number 2 we have, right? That we want to have a new firmware, and this is, from my point of view, the way to go, right? So let's break that up here and see another example relevant for us, and that's Specter So here we have the code, and we are focusing here on, yeah, on what we are focusing. We have the problem, if you remember, that the firmware is building, and then if you flash it on the device, it doesn't work, and we don't know why. And basically, what I did, I tried to analyze that situation with the AI, and created an incredible long document, right? So a product requirements document, a PRD, right? And the problem here is fixed firmware flash boot failure after MicroPython upgrade. And yeah, it has some scope. It has an executive summary. So let's maybe read that. Specter DIY is a Bitcoin hardware wallet. The project upgraded its MicroPython foundation from v1.x to 1.25, along with LVGL from 8 to 9. Problem, the firmware build succeeds, but the resulting binary breaks during the flashing process, fails halfway through, and the board fails to reboot successfully. This indicates a runtime or memory layout issue, not a compilation issue. Goal, debug and fix the firmware so that it successfully flashes to the board and boots properly. Develop debugging techniques and methods for onboard firmware debugging. Start with a simple Python test code before moving to the complex application in source. Okay, interesting. Yeah, so what we need now, we need to help the AI to get it hands-on. And effectively, I have never done that, right? I would say I've now worked around maybe 3 to 5 hours on that. And the main thing what I did, I tried as a kind of project manager to structure the problem for the AI, right? And when it's if you know Scrum and things like that, so this is the BMAT method. So the BMAT method tries to somehow work with Scrum, which is a process technique for building software. And what it does after creating these documents, which is more or less only about requirements and not so much about how stuff gets implemented, it created epics. Yeah, so this is, by the way, the same document, but somehow sharded, right? So so that it's easier for the AI to grab specific parts of the document. But then it created somehow an epic, which is more or less like a package of to-dos, and it's breaking down to stories. And the stories or the whole epic is more or less like establishing a debugging infrastructure, right? So, and that is getting the hands on with the device from the so the the AI needs to learn how the device operates and how it can control it from all kind of aspects, right? So yeah, and then we have things like, and I didn't know what all these stuff means, right? A JTAG SWD debugger, an OpenOCT, and the debugging workflow. Yeah, and we can now start Claude and see what the kind of status is. I give you a small hint. We have implemented the story 1 and 2, but not yet 3. So 3 is partially done here, but not completely. But I have done story 1 and story 2, and the story, and I show you how it looks like. Is there a board attached? So maybe I share my screen on my camera. I don't know whether it's so useful, but I just do it now so that you can see what is happening. And here's the same thing. Please use the Disco tool. And it might not even know what the Disco tool is because yeah, let's break it up. I have a special command to make it clever. So what this is now doing, it is reading through all these material, because that stuff is not for me. So it hasn't been created because I read it. It has been created for the AI to read it, to get context, to get context and guardrails, and an idea what the problem is and what we are trying to achieve, right? So I'm not sure how we have managed the Python setup, and so we might need to fix that now on the fly, because yeah, I'm not sure whether we even have a virtual environment here. Yeah, but so now explore the Disco tool. So that is a Python application which I developed together with the AI, or basically AI developed it. Or I just yeah, it's now reading the whole source code. I wanted to only start it, but yeah, anyway. In order to make it easier for the AI and maybe also for humans to interact with the system. Yeah, so that will, yeah, it is somehow here, I think. Scripts. Ah, yeah, great. Yeah. So here it's getting too small, maybe. So maybe now it's better. We don't need this one anymore. Yeah, it tells us what we have. So we have this kind of Disco tool, and it also helps us, but it also helps the AI to communicate with the board, right? And I did that within about, I don't know, an hour or so. And it was first Bash, and then I asked it to put it to Python, and it took about 5 to 10 minutes, and it all ported it to Python. So it has these kind of subcommands, and yeah, for OCD, for the CPU, for memory, for flash, for serial, and it has these kind of check commands. Please check. Yeah, and it's unfortunately, I don't know why I have it here, which Python 3. No, create a VNF and install the requirements. .txt. You might know that. It is the sharp edges from a demo, I would say. I think that this should be solved out of the box. And if you're doing with Python, you know what this is doing here. Ah, we are already in here. Board detected, both USB cables connected. Yeah, we can connect. It's now doing diagnostic test. We can see the output here if we want to. we want to go into that detail. Of course, we don't. Maybe you do, but I don't. We can now test the Ripple connection. Yes. Well, this is brand new, right? It's I mean, I started with it somehow last week, right? But I did it about, I don't know, 2 o'clock or so. I started with improving that, and I hope we see something reasonable here. I hope you can still hear me.
Yes.
Hello?
Yes, we can hear you.
Okay, great. Yeah, this takes a little bit too long, I would say. Because if it would succeed as it did an hour ago, I would say, then we could potentially, no Ripple response. So it's now rebooting the whole thing. Let me check what's happening. That's a great idea. Please do it. And you see here that, yeah, it has some tooling. It gives it best to try to get to work. And I basically say something like, yes, please do it, please do it, please do it. No idea. That's what a manager does to a technician if he has no idea. Yeah, let's do it, let's do it. And at some point in time, he says, well, we are now running in circles. Are you sure we are still on the right track? Right. Yeah, and I haven't unplugged it, so that's what a manager might do now, right? So if it's so we could unplug and replug it again. It would be great if it would be able to do that on it itself, right? And maybe it is doing that before Christmas. Let's see. No, I don't care. So I'm unplugging and plugging it again. Yeah, and the more autonomous that got. Oh, here, Ripple is not responding. That's a pity. So that's a demo effect, I would say. And we could go and try to tinker now. But I think you got the idea here, and that is what I hope somehow will solve, if we do it long enough, also the firmware issue, because it is able, or it's not yet able to, I think just recently I tried to read out memory and write it to files and all that stuff. So what I'm currently just doing, I'm helping it to get a better grasp on the devices, and to yeah, to interact with it, and figuring out what's wrong. And if it, whenever it has some kind of breakthrough, I try to push it into code, right? Which means improving the debugging document, or updating the stories, or whatever, right? Yeah, and I would say, I would break it up here so far. Um,
So maybe one thing we can also like include in this
yes, questions
call
maybe,
today
until
is
I'm seeking the answer.
yeah, what about Claude? Because maybe like say some words about Claude. I think it's 20. I can share it. It's 20 euro a month, and I'm using it also for other projects, because like I said, I'm not really a coder, but with Claude, it's really easy to code, honestly. Um, so it's, I think, 20 euro a month, and you're using like the pro plan, right? Which is, I
Which
think,
is a
five.
$100 per month, yes.
How much?
And I'm using it $100 per month,
Yeah,
which is, if you think about it from a developer point of view, is incredible cheap. Because if you get a tenfold kind of increase in effectivity and efficiency, $100 is nothing, right? So, it really is. I haven't hit any wall with this $100. So you're really, if anyone wants to, maybe one of the listeners is a developer who wants to go in with that, and this is really a lot. I haven't hit any wall. I was close, yeah, because what you have is basically time windows where you are only allowed to use so and so many tokens, and um, yeah, and then you have, I think, you have a 7 hour window or something like that, and then you have a 1 week window, right? And both are these kind of restrictions, and I haven't hit any of that yet.
yeah, but I already did a lot of times, honestly, with the like
Yeah,
20 euro plan. So you very fast go to like the end of the 20 and how do you call it, to the end of the, like, I think it's always like 5 hours. You get fast because it's thinking a lot and it's working a lot, and then maybe after like 25 minutes, when it's 25 minutes working in a row, or 30 minutes, then something in this time frame, then it's off, and you need to wait like 5 hours, then you can to restart it. And I'm not sure how often you can do this after it resets next week, because you have like, it's then, yeah. Maybe, I'm not sure if you already tested it for the Spectre, but there's also, if you just want to start for free, there's Google CLI. I also used it a little bit, and this is completely free. As a Gemini CLI. Did you tested it yet? Was the things you did currently with the Spectre?
sorry. No, I'm not testing different models so much, to be honest, right? So currently I'm using the best model, which is Opus 4.5, I think. And yeah, and I've heard, or my experience is that it's getting better and better and better with every model, right? So things which are not working 2 months ago might work with a model, and it might be much more clever and things like that, right? So yeah, does it answer the question?
Yeah, I think so. I think so. And I think what's cool is I have like watched a video tutorial, the Claude MD file, for example. Um, this is like read from the Claude AI, and I've heard that it's also used from other, like from every AI, because there are some around, and they are like compatible, like all are like compatible. So if you use then Google CLI, for example, it also reads the Claude file, and you don't need the Gemini.md file or something to create. So it works with different AIs, and maybe I didn't test it, but maybe it could make sense if you have like only the small plan of how do you call it, of Claude, that you make maybe like the easier tasks with Gemini CLI, so that you don't run out of tokens so fast, because I think Claude is better from what I tested yet.
Yeah, usually I would have stopped that much earlier, but yeah, for
We
here,
can't see your
I
stream right now, screen right now. So if you're
you
speaking
can't
about
see
the
the
screen,
screen.
then
Why you can't see the screen?
you stopped sharing it a couple of seconds ago.
Okay. Yeah. Anyway, we are more or less. Oh, we just. Sorry, I'm sharing again because I think we just. It was just able for some reason to found it. So it just said Ripple is
We see your
working. The
chat. We
issue.
see your chats. You streamed the wrong screen.
Yeah, that's great. Yeah, it's, maybe you have now the opportunity to cut something out.
Yeah.
Okay, that was the wrong screen. I think this was a better screen. Yeah, you see, Ripple is working. The issue was that JTAG hold stops USB interrupts. This is a new finding, which I have no idea what it actually means. And now I would go into detail and say, what do you mean by the issue was that JTAG holds stop USB interrupts. Is there an opportunity to improve the Disco script? USB interrupt handler stopped running. Host sends keep alive packets. Firmware can't respond. Host times out. Device disconnects. Blah blah blah. Disappears. Warn users before halting that USB quick halt, read, resume pattern, minimize hold time, auto resume. Let me check the current implementation, propose improvements. Here are the specific issues and improvements. Current problem. Blah 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 blah. Check all halt. Call halt, but never resume. No warning about USB disconnects when halting. Proposed fix. Yeah. Cool. So as you see, we've created yet another fix only in the control software, but when we keep improving that, we hopefully come to a great solution. That's it from my side.
Perfect. Yeah, I think we are done. Was like, I think very
Maybe Q&A.